first one is the Viptela secure architecture. So secure architecture, so let's explore the different components that make the SD-WAN architecture. So this architecture, SD-WAN architecture, must provide 4 essential roles. So the first role is the orchestration. Orchestration is a component that can facilitate or orchestrate the connectivity. Like when all the components comes up in the network, you need one component that can coordinate between, does the coordination between all the components and authenticate them and bring them up in the network, overlay network. The second thing is the management. So you need a component that can provide you management capabilities for the entire Viptela environment. The third thing you need is the control, a component that can enforce policies in the network. And the fourth thing that you need is a component that can carry the application data in the network. So these are the 4 requirements for a secure architecture. And for these 4 requirements, Viptela provides 4 different appliances. So for orchestration, the Viptela appliance is called vBond. For management, the appliance is called vManage. For control, the appliance is called vSmart. And for data, the appliance is called vEdge. So if you see the figure on the right-hand side, you see all these 4 components. This is part of the Viptela secure architecture. So vBond, vSmart, and vManage, these are controller devices, and they are completely virtual entities. They can reside on-prem or in the cloud. vEdge, it could be a virtual or a physical entity, and it comes in various form factors. We will see in the upcoming slides what are the different type of vEdge. So, but just to keep in mind that the controllers, they are all virtual entities. And the vEdge, it could be a virtual or a physical, and in most cases, it's a physical device. So vBond is basically your first point of authentication. So any device that comes up on the Viptela network, it has to first talk to vBond, get it authenticated from vBond, and then it can perform the other functions. vSmart is basically the brain of the overlay network. It is the place where you define all your control policies, your data policies, and all your tunnels from the edge devices, they get created to the vSmart. vManage is a centralized management dashboard where you go and you can monitor, you can troubleshoot your network. vEdge is the muscle of the overlay network, and the reason why I'm calling it muscle because it carries all the application and user data. So this is a device which works at the data plane, the vManage works at the management plane, vSmart works at the control plane, and vBond works at the orchestration plane.
So at this stage, is it appropriate to ask the question that
Sure.
One reason why Viptela is a little behind is because Cisco took a year to integrate the software into their ISR router series, which after that 1 year gave them a big competitive advantage. But it also added one more piece of terminology, which is that there is a vEdge, which is the original edge router from Viptela, and then now there is the cEdge, which is the Cisco ISR router. Would you kindly comment on that, please?
Yeah, there is a slide on that, so we will talk about it.
Thank you, sir.
There's a slide later on. Thank you. So the different functional roles of Viptela components, the vBond orchestrator, as I mentioned earlier, it's a primary authenticator for all SD-WAN components. It distributes a list of vManage, vSmart controllers to all vEdge routers. So when vEdge router comes up on a network, it gets a list of vManage and vSmart controllers that it needs to talk to, and vBond is the one that authenticates vEdge first and then provides the list of, once it is successfully authenticated, then it provides the list of vManage and vSmart controllers so that vEdge can go to the vManage, get its configuration, go to the vSmart, and build the tunnel. If vEdge is sitting behind a NAT, NAT is network address translation. Like for example, if your VH router is sitting on a private network and it is going out on the internet through through a public IP address, which is so it translates the private address into the public address. So VBond also does the net traversal function for the VEdge. Then the next device is vManage. It's a GUI-based network management system for the entire SD-WAN fabric. You can monitor, troubleshoot, and configure. It helps the administrator to perform software upgrades also. So if you want to upgrade any of the vEdge device in your network, you can do it from the vManage. You don't have to go directly to the vEdge and upgrade it. You can do it centrally from the vManage. So vSmart Controller, it enforces control policies. It uses a protocol called as OMP, Overlay Management Protocol, to build peering with all the vEdge routers. So all the control plane traffic that traverse between the vSmart and vEdge routers, it uses this OMP protocol. Excuse me. And then the vSmart controller, it get the routing information from each individual vEdge routers, and then it knows what is the best route for the vEdge. So, for example, if a vEdge want to go to a certain destination, the vSmart controller, it tells the vEdge router that this is the best route you should take. So, and it also distribute data and app route policies for the vManage, and we will discuss about these data and app route policies in the upcoming slides. So vEdge router, which is the fourth appliance, vEdge router handles the transmission of data traffic. It sits at each branch office and provide connectivity across the fabric. vEdge routers are offered as an appliance or as a software-only VM. So you can get a VM on an ESXi host if you want to generate a vEdge within your environment. You can get an ESXi host. You can create a VM and configure it as a vEdge. You can configure it on a KVM, AWS, or Microsoft Azure platforms. The best feature of the vEdge is the zero-touch provisioning, and we will discuss in the upcoming slide what exactly is zero-touch provisioning.